Hello students, welcome to Darasa Online. My name is Naftal Lucas Makombile. I'm teaching chemistry. Today I want to present to you the topic of carbonyl compound, and the subtopic that I'm going to present to you is properties of carbonyl compounds. So today's presentation, my dear students, will be based on the properties of carbonyl compounds. And I'm sure that by the end of today's presentation, you'll be able to apply the chemistry principles and the skills in solving day-to-day life's problems. And also, I'm sure that you're going to be very confident to solve different problems relating to this particular presentation. And today we are going to discuss particularly 3 chemical reactions from this particular part, because this is the continuation of the lesson that we started in the previous discussion. Now, the 3 chemical reactions that we are going to discuss are aldehyde condensation reaction. We are going to discuss about Cannizzaro reaction, and also we are going to discuss about Clemmensen reduction reaction. So I would like to take this opportunity to welcome you to connect with me till the end of this program. Now you're warmly welcome. So let's start to discuss about these chemical reactions. Number 1, we have aldehyde condensation reaction. Aldehyde condensation reaction, by definition, and I hope that you can be able to see the definition. Yes, it is very simple, right? When we talk about aldehyde condensation reaction, we are talking about the reaction between carbonyl compound with alpha hydrogen atom and the strong alkaline solution or acidic solution to give a new compound which contains hydroxyl group and a carbonyl group on the same compound. That is the definition. So this is the definition, is the reaction between carbonyl compounds with alpha hydrogen atom and a strong alkaline solution or acidic solution to give a new compound with both hydroxyl group and a carbonyl group on the same compound. But today's presentation will be based on the presence of strong alkaline solution only. So we're not going to deal with the acidic solution. So here we have also to understand what is all about alpha hydrogen atom. Now when we talk about alpha hydrogen atom, alpha hydrogen atom is the hydrogen atom bonded to alpha carbon. Bonded to alpha carbon. Now you can ask yourself, what is alpha carbon? Alpha carbon is the carbon atom which is directly bonded to the carbon of the carbonyl group. So it is very simple to understand this definition. So we can have some examples. Roman 1. This is ethanol. It is one of the examples of the carbonyl compound with alpha hydrogen atoms. This carbon is alpha carbon. It is bonded to this carbon with carbonyl group. So the hydrogen atoms bond to this carbon, they are called alpha hydrogen atoms. So this is one of the examples. Now for the case of ketone, we have this one. So this carbon atom, which is bonded to this one, you can have these are hydrogen atoms that you can see. So these are the examples of the compounds with alpha hydrogen atoms. Now, my dear student, we can proceed with our discussion to see, to proceed more with the explanation concerning aldo-keto condensation reaction, because here there are two terms. We have aldo and a keto. So aldo represents aldehyde, keto represents ketone. But condensation reaction, I'm sure that you can be able to tell what is it all about. It is the reaction between the combination between two or more molecules, either of the same compound or different compound, with involvement or without involvement of simple molecules like water, hydrogen chloride, and so on. So here we have aldo condensation and we have keto condensation. So let's start with aldo condensation. Yes. When we talk about aldo condensation reaction, is the reaction between aldehyde with alpha hydrogen atom and a strong alkaline solution to give a new compound with both hydroxyl group and carbonyl group. And here I've told you that specifically we are going to deal with the basic medium, that is alkaline solution only for today's presentation. So this is the explanation of aldo condensation reaction. Now, let's see some examples. One, let's take example of 2-ethanol. Reacting with alkali solution, which is sodium hydroxide. So let us see the mechanism of this reaction. Now, because there are two molecules of ethanol, let's take one molecule of ethanol starting reacting with the sodium hydroxide. Now sodium hydroxide, this will break to give hydroxide ion. Therefore, the first molecule and hydroxide group from sodium hydroxide. Now, what will happen? This hydroxide group, it will attack this proton here. And when this is taken, this bond will break, the electron will come to this carbon atom. Therefore, there we are going to have this one. This carbon will be negatively charged. And also this and this one will form water. Now what will happen? This electron will go to this carbon atom, and because of the carbonyl group is a strongly electron withdrawing group, therefore electron will be withdrawn to the oxygen atom in that way. Now this proton is released, and here comes a point to explain that carbonyl compounds are acidic in nature. What explains the acidic nature of carbonyl compound is due to the ability of donating a proton. Now how? The carbonyl group is strongly electron withdrawing drawing group. Now what happens there? If a carbonyl compound loses a proton, now an ion which will be formed will be stabilized by the localization of the electron in that carbonyl group. So it is very simple in that way. So carbonyl compounds are acidic in nature. That's why it donates a proton reacting with this one to form water. So when this happens, this compound here will be as follows. Here it will remain positive, negative, a double bond will be established there between this carbon and this carbon. And that one, electron comes here to become negative charged with hydrogen. So this is an ion. It is called inert ion. When it reacts, what happens? This electron comes back to this carbon atom and moving to here, this pi electron. Now, from there, this will be negatively charged. If it will be negatively charged, it will attack this carbon atom, making the electron also move to this oxygen atom. So here there will be a formation of the double bond. Therefore, we are going to form the following compound. This carbon will come and make a bond here. So we are going to start with this CH3, followed by this carbon, negative, then this carbon coming here, just go to hydrogen atom, followed by this one. But this carbon, there is a double bond with oxygen and hydrogen. So this compound will be formed. From there, what next? This one needs stabilization. Now from there, the water which is formed will act as an acid by donating a proton here. Therefore, this water which is formed will act as an acid by donating a proton. Therefore, this one will attack this proton and the electron move that way. So at the end, we are going to have the following product. When this proton is brought here, hydroxyl group will be formed there. So you can see, this is the new compound which is formed. It contains hydroxyl group and a carbonyl group in this same compound, and this OH. This is a reversible reaction. when these compounds are heated, you are going to get back these products, this reactant, which was used to give them. So this is a very simple illustration to explain aldehyde condensation reaction. Aldehyde with alpha hydrogen atoms, how they react with sodium hydroxide, and how the reaction is initiated. So having looked at this one, we can go to other one. Let us look at ketone. Now, my dear student, let's go to keto condensation reaction. When we talk about keto condensation reaction, that means here ketone with alpha hydrogen atoms are the ones which are involved. They react with alkaline solution, that is sodium hydroxide, to give the compound which contains both group, hydroxyl group and carbonyl group. We can see some examples. This one. So from here, when it reacts with the sodium hydroxide, 2 molecules are needed. What will be the product? We can get the product by seeing the mechanism. Let's look at the mechanism of this simple reaction. Now, one of the molecules starts reacting with sodium hydroxide. Sodium hydroxide will give hydroxide ion. This one will attack this proton, alpha hydrogen atom from alpha carbon, to give the following. This carbon is negative charged now because the electron will move to this carbon that way, because this bond will break electrolytically. If that is the case, this electron will move to this carbon and coming to oxygen atom here. Now, what will happen? I'm writing the product downward here. That is an ion which is formed, and also the product of water, because hydroxide ion and the proton will form water. So from there, my dear student, you can proceed with the mechanism. This is the first molecule reacting with sodium hydroxide. So we can get to the second molecule of ketone. Now, the second molecule of ketone, or propanone, react with that one. What will be the product? This electron comes back here, and this pi bond electron moves to this oxygen carbon atom. This carbon atom will attack this carbon here, and the electron will move that way. So what will be the products here? We write this one, and this carbon with that one, because the electron comes here, will be bonded to this carbon with the 2 hydrogen atoms. Remember, when we write this one is bonded to 2 alkyl group. The first one is this one, the second is this one. So this one is bonded to this one. The bond is formed there. Then we proceed with this one. When the electron comes back here, a double bond will be formed here. And that compound. So you can see the formation of this compound. Now, the water which formed will give the proton here to finalize the reaction. Now this will attack this proton, and the electron move to this one. We are going to form this product. So you can see, my dear student, this compound which is formed contains both group hydroxyl group and a carbonyl group. That is about keto condensation. So this is about aldo and the keto condensation reaction for those carbonyl compounds with alpha hydrogen atoms. Now there are other carbonyl compounds which do not contain alpha hydrogen atoms. They have also another reaction which is called the Cannizzaro reaction. So let us see the second reaction, which is Cannizzaro reaction. Now, Cannizzaro reaction, this one, it can involve, for example, halides with no alpha hydrogen atoms. For example, we have methanol. This one, it lacks alpha hydrogen atoms. The second example is this one. This is benzaldehyde. It lacks alpha hydrogen atom. The third one it also lacks alpha hydrogen atoms because this carbon is tertiary. There is no hydrogen atoms there. So these examples, they undergo Cannizzaro reaction. Cannizzaro reaction is the form of disproportionation reaction, whereby the compound is oxidized and reduced at the same time. So, my dear student, we can have the example there. Cut. Now, let's go to examples of the reaction. This is benzaldehyde. It lacks alpha hydrogen atom. So this one, when reacting with the sodium hydroxide solution, what will be the product? Here we make it 2. Now let's see the mechanism. The first one, this reaction is initiated by the hydroxide group from sodium hydroxide. Now this one will attack this carbon atom, making the electron to move to oxygen atom in that way. The product here will be this compound. Now this compound which is formed will react with another molecule of benzaldehyde. This electron will come back to carbon atom, and this proton will attack the carbon atom, electron will move to oxygen, oxygen atom here. So from there, we are going to form the following products. When this one electron comes back to come to carbon, there will be a formation of a double bond. So this is carboxylic acid which is formed. And this compound will be as follows. And this proton here. So this is negatively charged. The reaction is not yet complete. Now this one, because this benzoic acid can release a proton, we can arrange it this way. Now this proton will be released, and this attack this proton, making the electron to move that way. So the final product here, we are going to have this one. When this proton is taken here, alcohol will be formed. This is benzalcohol. But this one, it will be like that way. So this ion will combine with the sodium ion from the first part. Sodium hydroxide breaks down to produce sodium ion and hydroxide ion. Now this sodium ion will be taken there, and the product here finally will be as follows. This is sodium benzoate. So the overall reaction here, we can write it as follows. Sorry, let us write it properly here. We have carboxylate salt and we have the alcohol. So what can you see, my dear student, is that this one can be oxidized into carboxylate salt. So benzaldehyde can be oxidized to carboxylate salt and also can be reduced into alcohol. This is reduction. That's why I said at the beginning, Cannizzaro reaction here, we get the concept of disproportionation reaction. That means oxidation and reduction is taking place simultaneously. So this is the way you can see, and these are the products that can be given. So you can also try this mechanism by using methanol. Can you take a piece of paper and try that mechanism to do it on yourself? Yes, it is very simple. You can do it. So that is the reaction. That is all about Cannizzaro reaction. So we can finish with the last one. Let us finish with the last reaction. This is Clemmensen. Clemmensen reduction reaction. Yes, we can say generally that Clemmensen reduction reaction is the reduction of carbonyl compound by reacting it with zinc amalgam. When we talk about zinc amalgam, we are talking about the mixture of zinc and mercury in the presence of concentrated hydrochloric acid to give alkane. So that is Clemmensen. We can give the example here. This is ethanol. It can be reduced to form alkane. The alkane which is formed will have the same number of carbon atoms as the carbonyl compound. Or if we give the example of ketone, we are going to get alkane, which is propane from this one. So you can see the number of carbon atoms are similar to the number of carbon atoms present on the carbonyl compound. So this is Clemmensen reduction reaction. So you can be asked to define with the aid of chemical equation. So you have to define and give the equation. Some of the students, when they asked define with the aid of chemical equation, they are just giving only definition. So you'll be missing some of the marks. So it is very important. Now, my dear students, let's be back after a short break. Now, welcome back, my dear students, so that we can see some questions. Now, as I told you that this particular area also has got some problems which are very important. So let's go direct to see examples of these questions and how to solve them. Now, coming here, the first question says, using chemical equation, show how butanol reacts with the following compounds. The first one is hydrazine. The second one is phenyl hydrazine. The third one is lithium aluminum tetrahydride and the phosphorus pentachloride. So these are the reaction that is very important. So let us see how butanol, which is an aldehyde, reacts with each of the compounds that are given there. Now let's be on the board to solve one after another. The first one, butanol, this is Roman 1. Butanol reacts with hydrazine. Now, the reaction here will take place in a very special way. We are going to see. But it is important first to know how to write the chemical formula of this compound. Because you can have the knowledge, but if you don't know how to write the chemical formula of this compound, it becomes another problem. So butanol, which is an aldehyde, having 4 carbon atoms, can be written this way. Reacting with hydrazine, which is written this way. This is hydrazine. Now let us see what will take place on this particular compound. The reaction is simple. Let's see the mechanism. Remember, each nitrogen atom has got the lone pairs. Now this lone pair initiated the reaction. How? This lone pair attacks this carbon atom, making the electron to move to oxygen atom in that way. So here we are going to have the following compound. Nitrogen atom, this one, with 2 hydrogen atom, and this one, and there is a hydrogen atom there. So that is the compound that will be formed. And after these nitrogen atoms gives a proton to carbon, it becomes positively charged. Sorry, this becomes positively charged. Now, if that is the case, we can proceed with the mechanism. What will happen here is that this take this proton, and because these nitrogen atoms need stabilization, this sigma bond will break electrolytically, giving back the lone pair to the nitrogen atom. So here we are going to form the following compound. This proton will be taken there, OH will be formed with nitrogen, having its lone pair, NH2, as you can see. So from there, what next, my dear student? This proton as well will attack this carbon atom, making the electron coming to this one. If that is the case, this will become positively charged because it loses the proton. Now, and this will attack this proton. The bond between hydrogen and nitrogen will break. Now, nitrogen atoms will also get the electron with that lone pair which was lost. So we are going to have the following compound. That means this hydroxide and ion and hydrogen ion will form water. We are going to remain with, when this one comes here, it will become negative. But when electron is moved from carbon to oxygen, that means this will remain positive. And the electron comes here, it will be negative. Therefore, there will be a formation of a double bond there. Remember, there is hydrogen atoms there. As you can see. And that one forms water. So that is the product that is formed when butanol reacts with hydrazine. This is hydrazone. It is very simple for you to do that equation. From there, we can go to the second one. The second one says that butanol reacting with phenyl hydrazine. We can also see that a simple example. Roman 2. That is also very simple. You just write the formula. That is butanol. Phenyl hydrazine is written this way. That one. What will be the product? Let's see the little mechanism here as well. Now, from there, the lone pair of nitrogen atoms will attack this carbon, making the electron to move there. So we are going to form the following compound at the end. This one. It's together with hydrogen, so this carbon will make a bond with this nitrogen. The space is not enough, I can write it here. That one. So from there, you can see that this one, after it donates a proton, it becomes positively charged. Now, this will give electron to the proton, and the bond will break down to the nitrogen atom there. So nitrogen atoms as well will give electron to this carbon. So we are going to form the following product. Sorry, this will not take place first. Yes. That one. So this proton, this pi electron can be donated to this carbon. If that is the case, this bond will also break down. Let it write in this way. There will become positive charge because this proton will attack this carbon atom, and the electron moves that way. So this will take this proton, and this bond will break electrolysically, coming back to nitrogen atom. So at the end, we are going to form the following product. The double bond will be formed between that one with nitrogen, and that one will form water. So you can see condensation reaction, water is given. So that is a very simple reaction that you can do, my students. Now this one is very simple. I can just guide you. Lithium, aluminum, tetrahydride reacting with butanol. This is a strong reducing agent. So butanol is aldehyde. It can be reduced by this compound into alcohol. You can take a piece of paper and try to do this one by yourself. But maybe you can give some mechanism on the fourth part. Phosphorus pentachloride with that one. What will be the product? Let's see a little mechanism. Now, from there, this oxygen atom has got the lone pair. So this lone pair can attack this phosphorus atom because the electron will be taken by the chlorine atom because it is more electronegative to form chloride ion. So we are going to form the following compound. This one, after losing this lone pair, will be positively charged. One of the lone pair is lost, making a bond with phosphorus with 4 chlorine atoms and the chloride ion, this one. So these are the products. So the process continues as follows. Now what happens here is that to return back the lone pair on oxygen atom, this pi bond will break down. So this will remain positively charged. To stabilize this one, this chloride ion will come and neutralize this positively charged carbon. So we are going to have the following. This chloride will be taken there, And remember, this carbon had the hydrogen atom, so we put it there in that way. The lone pair of oxygen is returned. I can attack the phosphorus atom, making the electron to move to the chlorine atom, which is more electronegative. So we are going to form the following. This one, after losing the proton, will be positively charged. Plus the chloride ion. Now what will happen? To stabilize this one, that means this bond will break. When it break, it will be taken here. This will be negatively charged. This one, positively charged, sorry, because it loses the electron. Now this chloride ion formed will come and attack this one to stabilize this positive charge. So at the end, we are going to form the following product. Here we are going to have two, that one and phosphorus trichloride oxide. So this is the product will be formed, and this is nucleophilic substitution reaction. It is very simple. So generally, these are the products. You can write it here, overall reaction. It is very simple, my dear student, to go to those mechanisms. So you can try to do these ones on yourself. Now from there, we can go to the to part B. Now, for the case of part B, the question says, compound X and Y have the same molecular formula, which is given here. Now, compound X gives a positive iodoform test, but compound Y does not. Use the given information to suggest the structures of X and Y. What is all the functional group of X and Y? That is a very another simple question to do. First of all, we have to think. When you are given these problems, you have to think what is all about them. It is very important. Now, because we are given the molecular formula of X and Y, that is the molecular formula. And you are told that compound X gives positive iodoform test. If it gives positive iodoform test, that means it has got terminal methyl group. And we are talking about aldehyde and ketone. So automatically here, this one is either one of them is aldehyde, the other one is ketone. How do you know that this is aldehyde and ketone? If, for example, here we are told that X gives a positive iodoform test. That means X is the carbonyl compound, but it has got a terminal methyl group. So it is very simple. You can write it this way. 3 carbon atoms that way. To have terminal methyl group can be this one. So the carbonyl group is present between them. So you just fill the hydrogen atoms to fill the valence of carbon. Now, this is X, and it is ketone. And if that is the case, Y will be the isomer of it. It doesn't contain the methyl group, so it will be this one. Aldehyde. So when you look, we are going to have 3 carbon atoms, 1, 2, 3, as required. Hydrogen atoms, 3 plus 3, 6, as required. Oxygen atom, that one. Even for Y, we are going to have 5, 6 hydrogen atoms. Carbon, 1, 2, 3, as required. Oxygen, 1. So it is simple. Now, the functional group here, the functional group is carbonyl group, which can be written this way, or sometimes it is written this way. So it is very simple for you to understand that one, my dear students. Now, second example is this one. compound Q, which has an unbranched carbon chain, react with methyl magnesium bromide to give after hydrolysis compound R. Now, chromic oxidation of R gives this compound, which gives a yellow crystal product with 2,4 denatophenylhydrazine and a positive iodoform test. Now, I can guide you through this question. This is a very simple one. I can guide you. Now, if compound Q has an unbranched carbon chain, that means there is no any branch. It reacts with methyl magnesium bromide and hydrolysis. I'm sure that when you studied about alcohol, one of the preparation of alcohol is the reaction between a carbonyl compound and a Grignard reagent followed by hydrolysis. We get alcohol. That is a very simple. So this compound here, Q, is an aldehyde. If it reacts with the Grignard reagent, which contains methyl magnesium bromide and water, that means hydrolysis is water, we're going to get this alcohol. So R will be alcohol. And chromic oxidation of R. When we talk about chromic oxidation, we are talking about the oxidation by chromic acid. This is chromic acid. That is a mild oxidation. So that alcohol is oxidized, but there is a difference in number of carbon atoms between Q and S. Because Q will get another carbon from methyl group of Grignard reagent. So that means this Q will have 4 carbon atoms. So it is very simple. But this R gives a yellow crystal with this compound. We have seen about the chemical distinguish test between carbonyl compound with the other organic compound. So this 2,4 denatophenylhydrazine test for the presence of carbonyl group. So this R, as I said, is a carbonyl compound. That's why it reacts with this one. So it is very simple. Giving positive iodoform test, that means this carbonyl compound has got a terminal methyl group. So you can do it by yourself. This is a very simple one. So from there, we can proceed with the other part of the equation. Write down all equations for reactions mentioned above. So you can write the chemical equations. And the other one, give the formula of the possible isomer of Q that will give the same results. Ketones and aldehyde are isomers to each other. So that is how I can guide you through that equation. So you can write it and try to do it by yourself. Now, my dear students, carbonyl compounds are very important in your life. For example, when we talk about ethanol, they are used in silvering of mirror. When we talk about methanol, that is formalin. When you go to your biology laboratory, there are different specimens which are preserved there. The chemical which is to preserve them is formalin, but it can be used to make vaccines which can be used to kill different germs, bacteria, viruses, and other things. But also benzaldehyde, it can be used to make perfume, so it is used in the perfume industry. We have butanol, is a very important industrial solvent. So you can see it is very useful in our daily life. Now, hope today's lesson was very, very important. It is important to remember the conditions and reagents which are needed for the reaction to take place. So if you know the mechanism, it is very simple for you to understand these simple organic reactions. So it is important also to remember the definitions of the Cannizzaro reactions with aid of equations. I have given the mechanism. How carbonyl compounds react with the different compounds, I've given you the mechanism. Aldo condensation reaction, ketone condensation reaction, it is important for you to remember them. So I expect that today's presentation has given you a very good knowledge of answering different questions that you're going to meet in different examinations. Thank you very much for the time that you have used to connect with me, and I hope that we are going to meet next time. Thank you. Have a good time.